Hey, and welcome to this session of In the Labs with me, Becky. Today I'm going to show you how to create this awesome rocking bean chair. So let's just skip back a few days and look at what originally inspired me to create this awesome looking chair. So I wanted to create a cool, unique looking chair for our office space, somewhere where we could sit and discuss new ideas, somewhere where I could sit and think about new projects that I want to create, and something that is a little bit more wowy than the generic office furniture. So it got me thinking about chairs in general, and it got me thinking about a chair that I have in my back garden, and that is this hammock here. And so the hammock is basically a hanging metal frame, and the seat is a mesh that is attached to the frame using bungee cord. And so that's where my idea blossomed, and so taking to Pinterest, which is my favourite source of online inspiration. Highly recommend it if you've never used it before. It's a great place to get lots of different ideas for all sorts of projects. I began searching for bungee chairs and came across all sorts of different designs, and so this really was my starting point for me to come up with my own designs. And I really liked the rocker type design. I thought it would add an element of relaxation to the chair, which is only a good thing, right? And so the one I went with was this one right here.
So you can see it looks like a bean shape, hence why I've called it the bean chair. And so the idea is I'd have 4 straight panels that slot into the 2 main bean side panels of the chair to make the chair stable. Then I'd have bungee cord threaded between the 2 sides to create the actual seated area. Now, in terms of the chair rocking, I've done a little bit of research to ensure that the chair doesn't go past what they call the tipping points, that we don't tip over when we're rocking on the chair. And what I've learnt is that I'd need a fairly long curve that extends past the centre of gravity, which is where you'll be sat within the chair, to support the weight of your top half so that we don't tip back.
So let's take a look at the actual file, how I've designed it in the software.
Okay, so let's just open up the beanchair.crv file. So this is the file that you will have. Now I'm just going to talk through the key components, some of the key technicalities to think about with this project. So I'm not going to show you how to draw up this design. And so here are the key parts. So we've got one bean, we have another bean, so we've got the 2 side panels. We've got 4 joining parts that are going to slot together on one point here into one of the slot holes, and the other point here into the mirrored slot hole on the other panel. And you'll notice we've got these holes in the slot, so once this area slots into one of the slot holes, this part will be visible, and we're going to use one of these. This will be a peg that we're going to slot into the holes on either side of the joining parts to ensure that everything's secured in place. Right then, now in terms of the chair, I know I mentioned earlier about the tipping point, so I just want you to sort of visualise how you'd be sat in the chair. So imagine your head is looking at this panel here. Your head is going to be somewhere around here, your bottom is going to be somewhere around here, and then your legs will just hang over here. And so what I'm doing here is I'm creating more curvature behind us to ensure that we don't tip over, where the centre of gravity is going to be somewhere around here. So that's the rocking chair in terms of it rocking. Now, in terms of the file, what do you need to do if you're not working with the same material thickness that I am? So I'm currently working with sheet material that is 0.914 inches. So if I go to my layers tab, you can see I've got lots of different layers. You're more than welcome to have a look through. A lot of these sort of point out how I created some of the shapes or how I got things in line and so on. So have a look through those. I have a layer here called Original Slot Piece, Hole and Peg, and I've got a layer here called Dimensions. So if we just move up and over, we can take a look. So this is the main joiner part. Okay, now things that you need to look out for if you're using different material thickness is anywhere where it says 0.914. Okay, so this is currently 30 inches wide, so that's how wide the actual seat area of the chair is going to be. So it's quite large. You can alter this if you want to. Here I have a gap of the material thickness, which is this part here. So remember, this piece is going to slot into one of the holes, so I'm just accounting for that material thickness that will be in the slot. And then I'll have this hole here, which is pretty much the Z by the Z, so you can see that's 0.914 by 0.914, where I'm going to slot a peg in there. So the peg will go into this hole to secure it into place. The peg itself, you can see we've got it drawn at an angle where it's just over 1 inch at the top, 0.6 at the bottom, so it's going to slot in nice and easy at the bottom, and then we're just going to really apply force using a mallet, just to hammer that in to ensure that we secure this join in the actual slot hole. Now the slot hole, which is this vector here, you can see we've got a height of the Z height, 0.914. So if you're using different material, change this value here, and that's all you really need to do. If you want to change this, you want to change the actual slot hole, and you want to change the thickness there. Otherwise everything should really remain the same, unless you wanted to make things smaller. So once you've done that, you can just simply bring the slot holes in, position them around. Now, because we're cutting the holes out, we need to ensure that we include the fillets, as my round tool is not going to cut the corner of the slot. So we want to include dog bone fillets in there. So you can see I've filleted the slot holes. I've also filleted the slot holes for the joining parts and this area here, so we have a nice flush fit when we come to slot the joining parts into those holes. Now, as this is a slot together part, we must test those slot fits. So I've got a layer here called test area, just of vectors of the key areas that I need to test. So I've got the actual main joining part, which is just taken from this area here. I've got a peg, which is this one here, and then we've got the slot holes. And what I intend to do is apply various negative allowances to the slots to ensure that we can get a nice snug fit within each one of those. So we'll look at that in a second in the Toolpath side of things. I've got a hole here which is taken from the bungee holes. This is just to ensure that my bungee cord is going to fit into that 1/2 inch circle because the thickness of the cord that I'm using is 10 mil, so I'm just going to have approximately sort of a 2 mil give there. So I just want to check that before I go and cut all of the other holes out. Now, if I double click on the dowels layer, you can see that I have 6 circles highlighted there. They are the circles for my dowels. And the reason I'm using dowels is because this is a two-sided part. Why am I doing this as a two-sided part? Well, because where we've got these holes, you'll notice I've got lines going through each of those holes, and those lines I'm going to use the fluting toolpath with a large ball nose just to create a nice flute going in and out of the hole. And the reason for this is so that when the bungee cord is threaded through each of the holes, over time you may find that the bungee might split at the plywood because of the tension that is on the actual material, and so by putting these flutes in, I'm hoping that's going to help sort of reduce the wear and tear on the actual wood itself over time. Then you'll see in red I've got a series of circles. Now these red circles are my holes for screws. Now when I say holes, it's not really a hole. I'm just simply going to apply a toolpath that's just going to scrape at those holes, purely for me to know where's safe for me to screw in my material to my machine bed for extra secure hold down. So I'm going to start off just by screwing the 4 corners, then I'll run a toolpath that's going to cut these holes, so it's literally just going to scrape. I'm only cutting down ever so finely, and then I could then secure it with screws, so I know that we're not going to hit anything when we come to machine everything else. So that's pretty much the file setup. So let's move over to the toolpath. So just going to switch over to the toolpaths tab. Now I'm only using 2 tools to cut this out. That is a 1/4 inch compression cutter, because we are working with ply. I want an up and downward cutting force so we don't splinter the surface of the material on both sides, and we're going to use quite a large ball nose as well for our fluting. So running through this, if we just tile our windows, so I've got my pocket screw hole, so we're going to just simply just come down ever so slightly, 0.04 of an inch, and then I can screw my screws in to secure that in place. Then we could look at taking all of those test vectors, so you can see I've got them selected here, they're all highlighted here. Let's just run through the sort of preview of those visible toolpaths. So that's what it'll look at. I've also got a profile to actually cut the test section out as well, so we can preview that. Profile cutout test part, that's the one I want, so preview that. There it is, cut out. And if we just come over into the 2D view, and if I just switch on the solid preview for the slot pieces, I'm just going to select all of those slot pockets. You'll see in the name we've got test 1 0 allowance, that's this one here, so we've not applied any form of allowance here, it's just as the vector is. And we've got negative 0.1, so all we're doing is we're just over cutting, so anywhere that's purple is what will be cut away. So here we're cutting past negative 0.01. This one is test 3, negative 0.02, and then test 4 is negative 0.025. So we're just going to basically test the various allowances with this part that's going to slot in place to ensure that we can work out what the best fit is. Once we've worked that out, then I'm going to change the actual toolpath for the pocket slot holes. So you'll see in the name here I've called it pocket slot holes need to add allowance, and must remember to add in the negative allowance. So how do you add that allowance in? Well, that is this section here, so I'd put a negative whatever worked in here and then calculate that. So once we've done the test, we're happy with everything that we got there, we can then run through everything else. So we'd do the pocket slot holes with that allowance, pocket the peg holes, okay, so just like so, very simple. You can take a look in depth at these toolpaths. We've got a profile cut out here. You'll notice that I do have a lead in here. I also have a ramp, and that's just to ensure that I'm keeping that cutter away from the side of the part so it doesn't damage the actual cutout of the parts. That's why we're sort of leading in there. Profile the pegs up the top here. We've got the dowels just cutting partially into the material. Profile the holes, so that's all of the holes for the bungee cord. And then we're going to do a tool change, so let's just preview that as it is so far. So preview the visible toolpaths, so that's what it's going to look like. And then for the actual fluting, if you double click on there, you can see I'm using a 0.4 inch ball nose, cutting down just under 0.2. I'm going to ramp at the start and end, and so what will happen is the tool is going to come in, it's going to ramp down, and then it's going to ramp up again as it gets to the end, so we create a nice fluting effect. So if we preview that toolpath, maximize the 3D view, we can see how the fluting looks there. Perfect. Right then, so you'll notice I haven't cut out the pattern on this side, as I've purposely left it to cut on the other side because I don't want to apply tabs to all of the different sections, because that's going to be time consuming, it's going to be a nightmare to clean up. And so my plan here is to add some double-sided carpet tape on top here, so when we flip the material over to cut the bottom side, if we switch to the bottom side there like so, I can then cut out the crisscross pattern with everything secured in place because of the tape hold down. At least I'm pretty certain that is going to hold it down. So on the bottom side, so our first operation is to machine the dowel holes into our spoil board. So your sheet of material is not on the bed at this point, you're just machining the dowel holes into the spoil board, where we're going to set our Z0 to the material, the machine bed on this side. Okay, so we're going to do the spoil board, put that in, and then we're going to go ahead and then secure the material back onto the bed, locating in those dowel holes. So we've got alignment in X and Y for the top and bottom sides, and we're simply going to run that profile pattern like so. I've got no tabs in here, I'm just hoping that that tape is going to hold all of these pieces down, and then we're going to finish that off with the fluting entry and exit holes for the bottom side. So when we preview this side, so if we just preview those visible toolpaths there, this is what our finished part will look like. And so pretty happy with what we've got here. So at this stage, ready to save out those toolpaths, so we'd save them out, and then we could go back over to the labs to actually run that on the machine. So let's head over to the labs.
Okay, so we've got the file all set up, so now we're just ready to go and set our machine up. So let's take a look at what we're going to use for this build.
So we're going to use sheet plywood. We need screws to hold the plywood down into my machine bed. One of the tools I'm using is a 1/4 inch compression end mill, or an up and downward cutter, and the reason that I'm using that is because I am working with plywood. I want the force of the downward cutter going down into the top surface, and then as the tool reaches the bottom of the material, I want that tool to be pulling upwards so that we don't splinter the layers that we've got in the plywood. Now, if you don't have a compression cutter, that's not a problem. The way you could get around this is just by using a standard downward cutter, but just machine halfway down on both sides, and that should give you the same effect. The other tool we're going to use is a 0.4 inch ball nose for the fluting. We're going to use dowels for the location holes to match the top side with the bottom side. I'm going to use double-sided carpet tape for extra hold down. And we're going to use 30 meters of 10mm thick bungee cord, and then we're going to use sanding and finishing materials to finish the part.
Okay, so we've got the machine set up. So the first toolpath we're going to run is a pocket toolpath that's just going to basically mark areas on the big sheet that we're using for us to put our screws in, just for extra hold down because we're working with such a large area. So let's run that one. Okay, so now that our material is secured to our machine bed, the next step we're going to take is cutting our test area out. So the idea behind doing our test cut is to ensure that we have perfect fit with our slots together parts. So we're going to try out various allowances, as you saw in the software, to see what fits best, and ultimately this is going to save us time and material by doing this little test area. So let's run the test file. Okay, so here is our test part, all detabbed. I've got the actual piece that I want to slot into those holes. So as you've seen in the software video, we've got 4 different pocket holes. We've got one at 0 allowance. There's no allowance whatsoever, it's just as it is. Over here we have negative 0.01. Here is negative 0.02, and then we have the largest allowance at the bottom right hand corner here, which is negative 0.025. So we're just going to test the fit of our piece that's going to go inside to see which fits best. So we can see at 0 we are struggling to get that in. Okay, I'm not going to be able to get that in, so we'll try the next one, which is negative 0.01. got a nice fit in there, it's not too tight, not too loose. We'll pull that one out, see if we can get any more of a better fit anywhere else. Okay, now negative 0.02 is very loose, and I imagine that the negative 0.025 is going to be much looser. So I think I'm going to go with the negative 0.01 in this case. So that will just simply slot in. I've got my peg, and then that peg is just basically going to secure that in place where we slot that in at the back. Okay, one last thing I need to check is the hole for the bungee cord. So I've got my bungee cord right here, and I can see that we've got a nice fit in there. So now all I need to do is just alter the main file to ensure that I've set all of those slot holes to have a negative allowance of 0.01. So I'm going to do that, and then we're going to go and run the actual file. Okay, so we're pretty much done with the top side now. All we need to do is take the material off, flip it over, and then cut the few toolpaths that we've got left for the bottom side. Now I'm actually going to call it a day today, and we're going to look at machining the bottom side tomorrow. And the way I've set this file up enables me to do that. So tomorrow, our first operation will be to machine the dowel holes of the bottom side directly into our spoil board. And then what we could do is we could put our dowel pins into the dowel holes of the top side, flip the material over, and we can locate them to the dowel holes that we've cut into the spoil board on the bottom side. That way we have perfect alignment in X and Y on both sides. So let's fast forward to tomorrow. Okay, so it's day 2 and we're back in the labs. We've took the sheet of material off the machine bed. So our next operation is to drill the dowel holes of the bottom side directly into the spoil board. Now before I do that, I just want to think about the inside part of our bean shape. So as you've seen in the file, we've got a lot of cut out areas, and I don't really want to put tabs in there. That's going to be a lot of effort to remove them and clean them up. So I'm going to use a magic trick where I'm going to use double-sided carpet tape. And we're just basically going to tape up the 2 beans, and that will ensure that I'll have a nice hold down for all of those cut out parts. So let's go and do the dowels, and then we'll flip the material over. Okay, so we've finished machining the bottom side. You can see this is one of the pieces. The tape's done its job, and you can see by looking at the bed, all my parts are held in place apart from the ones that I've took out. So all I need to do now is take everything off, detab it, give it a good sand. I've got my helper here, Sean, as we're working with quite a large part. It's a 2-man job.
So here, myself and Sean are assembling the chair, slotting the joining parts into the slot holes, and you can see that it inserts nicely, it's not too tight nor too loose, and that's thanks to the test that we did earlier trying out the different negative allowances. Then to lock the piece in place, you can see that we're hammering the pegs into the slot holes, and so the shape of the peg enables us to initially insert the peg, and then with the force of the mallet we can secure it into place where it's not going to move anywhere, and this will ensure that the chair is structurally sound. So the first step here is to unravel the bungee cord so we can locate the halfway point of the overall cord, as this is crucial for us creating an even thread throughout the chair. So what we did was we tied a cable tie where the halfway point was so that we didn't lose it, and that meant that we could keep everything even. Okay, so the first initial thread, I decided to try the chair out, and you can see that it just fell through. It obviously didn't have this taut enough. So we tried again, but this time with 3 pairs of hands, and this consisted of a lot of strength and resistance to make the cord as taut as possible, and this allowed us to bring the cord to go through every hole as intended.
Okay, so here we have the assembled bungee chair. You can see we've got the bungee cord in place. We've made it extra taut, ready for us to put some cushions on. So I'm going to call it a day, and tomorrow we'll get the cushions sewn up, ready for us to enjoy. Okay, so the last thing that we need to do is create the cushions. So I'm doing this in a real sort of cheap, easy way, where I'm going to use pillowcases. So I'm going to take 4 pillowcases, your standard normal size pillowcase, and I'm simply just going to sew them together along the horizontal, so we end up with a really long sort of lounger style cushion, whereby we'll insert the actual pillows into each one of those cases that are sewn together. Now you don't have to do this, but for my chair I just want to make it a little bit more comfortable by adding in that cushion. Okay, so I'm going to start sewing and then I'll show you the result at the end. Okay, so I've spent a couple of minutes sewing up each one of those cases together, so now we have a really long lounger base for us to sit on. So all I need to do now is input the cushions and then we can try it out on the chair. Okay, so I've put all of the cushions in each one of the segments, so the last thing I need to do is place it on the bean chair and try it out. Okay, perfect fit. Right then, now for the fun stuff. Oh, this is amazing. Okay, so I'm going to leave you there while I sit and relax in my bean chair thinking about the next Vectric project that I'm going to create. Now, if you want to have a go at creating your own bean chair, then you can download the files from your V&Co portal account. I'll link you up at the bottom. If you do end up creating your own version, then please feel free to share that with us on the Vectric forum and across all the social media platforms. And if you like this video, give us a thumbs up, and if you're not subscribed yet, please subscribe to our channel for instant updates of the new project videos that we're creating. Happy making!